Welcome all. In this lecture, we are going to solve a question based on block diagram reduction technique. In this question, we just need to determine C of S over R of S for the system whose block diagram is given like this. Here, the ratio C of S over R of S is nothing but a transfer function. A transfer function can easily be determined by solving the block diagram using block diagram reduction technique. So let's start to solve this block diagram. Here, by analysis of this block diagram, we have to find out a point from which we just have to initiate to solve this block diagram. So from my analysis, I can see that here is the two blocks having the gain G1 and G2 that are connected in series combination, and another block is there having a gain G4 in the parallel combination. But this takeoff point is creating a problem here. So we should have to shift this takeoff point at this position or at this position. So let's talk about the case in which we shift this takeoff point here. So if we shift this takeoff point here, then it will again create a problem because this takeoff point will come in between this gain G2 and this summing point. So the only remaining choice is we have to shift this takeoff point before G1. So our first step is shifting takeoff point before G1. So let's find out that what will happen if we shift this takeoff point before G1. So if we move this takeoff point before G1, then the gain G1 will get multiplied with this gain H3. So here H3 will become H3 G1. So let's redraw this whole block diagram. So this is R of S, which is applied as an input to the summer. This is positive polarity, and here is the G1 block, and the G1 block is directly being connected with G2, and this is another summer which is connected with G3, and the final output, that is C of S. Here is a takeoff point that is having a block G4 which is connected with this summer, and since we shifted this takeoff point before G1, therefore it will lie here, and here is the block of H3. Since H3 become H3 G1, that's why we write H3 G1 here, and it is connected with a summer with positive polarity. Now here is another takeoff point with feedback path gain equals to H1, which is connected with the summer with negative sign, and here is another feedback path gain, that is nothing but H2, which is connected with this summer with negative polarity. So this is the simplified block diagram. So now have a look at these blocks. Now G1 and G2 is connected in series, and G4 is connected in parallel to G1 and G2. So let's have a look at this series and parallel combination. So if G1 and G2 are connected in series, then the overall gain will now become the multiplication of G1 and G2, that is G1 G2, and this G1 G2 is connected in parallel with G4. So the overall gain will now become equals to G1 G2 plus G4. So our next step is solving G1 and G2 in series and G4 in parallel. So let's redraw this whole block diagram. So here is R of S that is applied as an input to the summer with positive polarity, and here is the equivalent gain that we have calculated, that is equals to G1 G2 plus G4. We write this block in place of this whole system, that is series and parallel combination. After this, G3 is directly connected, and here is C of S, that is output. In between this, here is a takeoff point having the gain H3 G1, and this is fed to a summer with positive polarity. Here is a negative polarity through which a feedback gain, that is H1, is connected by a takeoff point after G3, and with negative polarity and another feedback gain, that is H2, is also there. So this is a simplified block diagram. Now let's analyze that what will be the next step. Now here this block and this block is in the series combination. So the overall output of these two blocks will nothing but the multiplication of the gain of these two blocks. So the equivalent gain will now become G3 multiplied with G1 G2 plus G4. So this is the equivalent gain which will come after the multiplication of these two blocks. So let's redraw the whole block diagram. So our next step is solving the blocks connected in series. So the equivalent circuit will now become, here is R of S that is applied to the summer with positive polarity, and the summer is then connected with the equivalent gain that we have calculated, which is equals to G3 multiplied with G1 G2 plus G4, and the output of this block is connected to the C of S. Here is an takeoff point which is being connected with a feedback gain, that is H1, and here is another takeoff point that is connected with the gain H3 G1, which is fed to the summer with positive polarity, and here is a negative polarity through which this feedback gain is connected. And after that, here is another feedback gain, that is H2, which is connected and fed to this summer with negative polarity. So this is the simplified block diagram. Now let us analyze that what will be the next step. So we have just discussed the 3 tricks. So the first trick was we have to form a feedback path. So if we try to make a feedback path, then this is a takeoff point which is creating a problem, because this is the forward path gain and these two are the feedback path gain, and it will become a perfect negative feedback system. But here is a takeoff point which is creating a problem. So we just simply need to do is we need to shift this takeoff point after this block at this position, so that this circuit can easily be simplified. Let's redraw the complete image of the circuit. So shifting the takeoff point in right hand side, we get R of S that is applied as a summing point. Here is a negative feedback. Here is a gain G3 multiplied with G1, G2 plus G4. Now it is directly connected with the output C of S, and here is a feedback, that is H1. And it is being fed to another summer here with a negative polarity, and this is being connected to the another feedback gain, that is H2, and it is fed to this summer with negative polarity. Now if we shift this takeoff point after this gain block at this position, then what will happen? This whole gain of this block, that is S3G1, will get divided by this gain. So H3G1 will now become H3G1 and divided by with this gain, that is G3, G1, G2 plus G4. So this is our new gain. And since we shifted this takeoff point at this position, so here is this position from which another feedback gain emerged, having the gain equals to this H3 G1 over G3 G1 G2 plus G4. This is the complete block, and it is now fed to this summer with positive polarity. So this is the rearrangement of this block. Now here is a feedback system in which the feedback, that is H1, is connected with a negative polarity, and also H2 is also connected with a negative polarity. So we can also draw this and rearrange it so that the H1 will get multiplied with H2, because H1 and H2 are in series. So the new gain will now become multiplication of h1 and h2, and this h2 will also in series with this path. So this h2 and this block gain is also in series. That's why this also get multiplied with each other. So the new gain will now become h2 multiplied with h3 g1 over g3 g1 g2 plus g4. So this is a new gain. Let's redraw this whole diagram. Since h2 is connected in series, so the new diagram will be R of S, that is applied to this summer, and here is again G3 G1 G2 plus G4, and here is an output C of S. Here is a feedback gain H1 H2, and also here is another feedback, that is nothing but equals to this term. So H2 H3 G1 over G3 G1 G2 plus G4. So this is the block. Now this is being connected to the summer. So here is a summer. This is a negative polarity and it is positive polarity. So this is being connected with this, and the whole summer will directly be connected with this summer with negative polarity. So we can apply the parallel combination rule because this block is in parallel combination with this block, so we can solve it easily. So let's analyze that what will be the new gain after solving these two blocks in parallel. So the new gain will now become the difference because here is a negative symbol. So the new gain will become H2 H3 G1 over G3 G1 G2 plus G4 minus, because it is connected with negative, that's why we write minus here, H1 H2. So this is the new gain after solving these two branches. So our next step, that is step number 4, will be solving the blocks in parallel combination. So here is an R of S that is applied to the summer with positive polarity, and here is negative, and here is G3 G1 G2 plus G4, and here is an output, that is C of S. Here is a takeoff point which is being connected to the new gain that we have calculated, that is nothing but H2 H3 G1 over G3 G1 G2 plus G4 minus H1 H2. So this is the new block of gain in feedback, and it is now directly been connected with this summer. Now here is a feedback system. Here is a forward path gain and here is a feedback path gain. The feedback path gain is connected with a negative sign here. So this is nothing but a negative feedback system. So our next step is to solve negative feedback system. So let's calculate the overall output after calculating this negative feedback system. Since the negative feedback system having the transfer function equals to nothing but T of S, that will be equals to G over 1 plus GH. Why it is plus sign? Because it is a negative feedback. That's why we write plus here. Now here the forward path gain, that is G value, is nothing but this value, and the feedback path gain, that is H value, is nothing but this whole value. So substituting the value of G and H, here we get the transfer function equals to G3 G1 G2 plus G4 over 1 plus G3 G1 G2 plus G4 into this whole term, that is H2 H3 G1 over G3 G1 G2 plus G4 minus H1 H2. So this is the gain. Now let's redraw the control system or the simplified control system. So here is the R of S, here is a forward path gain, and here is a output, that is C of S. We have to copy this whole term here. So G3 G1 G2 plus G4 divided by 1 plus G3 G1 G2 plus G4 multiplied with H2 H3 G1 divided by G3 G1 G2 plus G4 minus H1 H2. Now after calculating and simplification, we get the ratio of C of S over R of S equals to G4 plus G1 G2 multiplied with G3 whole divided by 1 plus G1 H2 H3 minus G1 H2 G2 G3 H1 minus G3 G4 H1 and H2. So this is the C of S over R of S ratio, and it is our final result that we need to calculate according to the question. So in this way, by the help of block diagram reduction technique, we can easily solve our questions. Thank you. If you like my videos, then do subscribe my channel and please hit the like button.